All right. So if a rock takes 0.75 seconds to hit the ground after being thrown vertically downward from a height of 4.8 meters, calculate the initial velocity of the rock. Okay, so I got a cliff, and the rock is being thrown down with an initial velocity that we don't know. Okay, the acceleration is equal to 9.81 meters per second squared, and s, the displacement, is equal to 4.80 meters. We're trying to calculate the initial velocity, okay? And that's all the information that they've given us. So let's go back to our SUVAT table. S is 4.88 meters. U is what we're trying to find. V, we don't know, but they didn't give us that. 9.81 meters per second squared. And T, I don't know. Oh, no, T we know. It's 0.75 seconds, okay? So with all those variables, how would I calculate the initial velocity of the rock? Okay, let's see which formulas we can use. We have S equals UT plus 1/2 AT squared. Now that would be an interesting problem. Okay, we can definitely put that together to solve for U. That's probably what we're going to do. So S is equal to 4.8 meters, which is equal to U times 0.75 seconds plus 1/2 times 9.81 meters per second squared times 0.75 seconds squared. Okay, and then if I rearranged everything, so 4.8 meters minus okay, that should give us 2.72 meters per second. Okay, a clown throws a ball upward with an initial velocity of 10 meters per second. Calculate the maximum height reached by the ball. Okay, so remember a ball is going to go up and then it's going to come down. Okay, when it reaches that top part, my final velocity is going to be equal to 0 meters per second. My initial velocity is 10 meters per second. And my acceleration, remember acceleration is working against that ball, is going to be negative 9.81 meters per second squared. Okay, so we're looking for the maximum height. That's what the question is asking us. We want to find that. And our initial velocity is 10 meters per second. Our final velocity is 0 meters per second, and we have negative 9.81 meters per second squared, and we don't have t. So we can use this formula. V squared is equal to u squared plus 2as. So v squared minus u squared divided by 2a is equal to s. All right, so 0 meters per second squared minus 10 meters per second squared divided by 2 times negative 9.81 meters per second squared is equal to s. And what is that? Okay, s is going to be 5.10 meters. Okay, now to calculate the total time taken to reach the maximum height, okay, I can plug that into a different formula to find time. And that formula, the simplest one, would be a is equal to v minus u divided by t. All right, so t is going to be equal to 10 meters per second, which is going to be the difference between v divided by 9.81 meters per second squared, and that should give us a total time of 1.02 seconds to get to the top. An amusement park ride called the Drop of Doom allows people to experience free fall from rest for a total distance of 27 meters before slowing them down. Calculate the final velocity experienced by the people before the ride begins to slow them down. So this is a free fall for 27 meters. Okay, so if I fall for 27 meters and my acceleration is equal to 9.81 meters per second squared, and my initial velocity is equal to 0 meters per second because he's falling from rest. Okay, all of those variables should help me solve for the final velocity. How are we going to calculate our final velocity? So let's find a formula for that. Okay, so we're going to make our SUVAT table. S is equal to 27 meters. U is 0 meters per second. V is what we're trying to find. My acceleration is 9.81 meters per second squared. Time we don't have. Okay, so what formulas can we use for that? So V squared is equal to U squared plus 2AS is something that I can see that we can use. Okay, and V is going to be equal to the square root of 0 meters per second squared plus 2 times 9.81 meters per second squared times 27 meters. If I solve for that, it's going to be 23 meters per second. Okay, that's what we got there. Now, finally, the tough stuff. We're throwing stuff. The two guys in the picture are playing an interesting game. We solved this one in class. Okay, so I'm sure that you guys, if you took your notes in class, you'd be able to do this one. But the two guys in the picture are playing an interesting game where they slide coins off a table and try to land them on a bullseye. Okay, assuming the guys roll the coin at a horizontal velocity of 0.3 meters per second and the table height is 1.25 meters and the acceleration of gravity is 9.81 meters per second squared, predict how far the bullseye must be placed from the edge of the table in order for the coin to land directly in the center of the board. Okay, so we worked this out together in class. And this is a projectile motion problem where you need to do two things. Okay, the first thing you need to do is calculate the time of flight. And then the second thing is then to calculate the range. Okay, how far horizontally will that object fly after determining the time of flight. So remember, the time of flight, that when that coin slides off the table, the time of flight is going to be dictated by gravity. The time it takes for that object to fall that particular distance off the table. Okay, so how long is it going to take? And that time is limited by the height of the table and gravity. Okay, so let's figure out the time of flight first. Okay, so the time of flight is going to be based on the fact that the height of that table is 1.25 meters, okay? And the initial velocity of that coin falling is going to be 0 meters per second in the downward direction, okay? The acceleration is going to be equal to 9.81 meters per second squared in the downward direction, okay? So for the time of flight, I'm going to create a SUVAT table. 1.25 meters is the height of the table. My initial velocity is 0 meters per second. My final velocity, we don't know, but that's not what we're trying to find. We're trying to find the time of flight. My acceleration is going to be 9.81 meters per second squared, and the time is what we're trying to solve, okay? So S, U, A, and T. Which formulas do we have for that? S is equal to U, T, plus 1/2 AT squared. So 1.25 meters is equal to 0 meters per second times time plus 1/2 times 9.81 times T squared. Okay, if I rearrange all that, because 0 times time is going to be 0, I am left with 1.25 meters is equal to 1/2 okay, so then if I rearrange this, I can solve the square root of 2 times 1.25 meters divided by 9.81 meters per second squared is going to be equal to the t. and that's going to be my time of flight. Okay, so 2.5 divided by 9.81 is going to be my time of flight. Okay, once I have my time of flight, I can then use that to calculate the range. Okay, so this coin is traveling at a horizontal velocity of 0.3 meters per second, I think. Yes, so the coin is traveling at a velocity of 0.3 meters per second. Okay, so the range is going to be equal to, because it's a constant velocity, S is equal to velocity times time. That's for constant velocity. Okay, so that coin is traveling at a constant velocity, and the time that it travels is limited by the time of flight, which is the time it takes to drop to the ground, using that formula. So S is equal to 0.3 meters per second times the time, which is going to be 2.5 divided by 9.81. Okay, whatever that solves to be. Okay, and in the end, you would get a distance, I think was around 0.15 meters. Yeah. All right. And that should be the answer for that. Very important problem to know how to do, because I bet you it'll be somewhere on your exam. Okay. Then a student launches an arrow horizontally from a 100-meter cliff. Calculate the horizontal velocity if the arrow lands 45 or 40 meters away from the base of the cliff. Whew. These are tough problems. Okay, but very good. This is a 100-meter cliff. Okay, and if I have my arrow and it's flying at an unknown velocity, okay, but it's going to land at a distance of 40 meters away. Okay, in order to answer this problem, you have to work everything out backwards, okay? Same thing, you need to first calculate the time of flight using this relationship, and then after calculating the time of flight, you then use this formula to be able to calculate the velocity, okay? So step number one, I would still have to calculate time of flight, okay? And the time of flight, if I make my SUVAT table, S is 100 meters. U is 0 meters per second. Okay, that arrow has 0 meters per second in the downward direction. It's all a constant velocity in the horizontal direction. V, we don't know, but that's not what the question is asking for. My acceleration is 9.81 meters per second squared. And T is what we're trying to find, okay? So, like in the last problem, we used the formula S equals UT plus 1/2 AT squared to be able to solve for time. And because my initial velocity is 0, that cancels out. So that becomes something simpler. S equals 1/2 AT squared. Okay, and so S is 100 meters is equal to 1/2 times 9.81 meters per second squared times t squared. Okay, now to solve for t, it's going to be 200 divided by 9.81 is equal to t. Okay, so whatever that's going to be, 200 divided by 10, like square root of 20, which is around, I think it's somewhere around 4.8 seconds. I might be off, but it's around something like that, 4 point something seconds. Okay, is equal to t. I'm not using my calculator. All right, and then once I've calculated the time of flight, in order to calculate the velocity, okay, S is equal to VT is my horizontal displacement. Okay, so to get the velocity, S over T is equal to V. S is 40 meters. T is 4.8 seconds or 4.56 seconds, whatever that T is. That might not be 4.8. And the answer should be 8.86 meters per second. So whatever 200 divided by 9.81 and the square root of that, that's the time. I can't remember exactly what that is. And then if you plug that into here, 40 divided by that number should give you 8.86. Probably it's not 4.8, probably it's 4.56 or something seconds. Okay, that's it.